Well, he is the original author of Free Switch. He has 25 years of experience in software engineering, beginning with the web hosting boom in the mid-90s. He founded Free Switch in 2005, along with the first ClueCon, if any of you had been here, which you weren't, so you missed out. And today, the Free Switch platform is used by all kinds of enterprises around the world. Everyone in this room, I hope, is familiar with it or knows what it is. He's also the founder of SignalWire, along with Sean Heine and myself back in 2017, and is just an all-around amazing guy. Please give it up for Mr. Anthony Minessale.
Wow, we're back. It's great to finally be back and have a crowd and be able to talk about some of this stuff. Like Evan said, I'm Anthony. I'm sure you've seen me around. What I want, do you guys want to put up the, is my feed working okay? Yes, okay. So, I wanted to just start out by remembering that ClueCon started in 2005 for the first time, and we had no idea what we were doing when we did it, but we knew that it needed to exist. And we communicated a lot of ideas at that conference that really kind of led to many of the things that we use every day. We put many years into trying to go from this complete world of kind of uncharted area and jungle and kind of pave the path through it so that some of the things that took a lot of work could suddenly be easier to do because there's much more to build on top of it. And in computers, sometimes when you're building software or products, you'll find that like the thing that's cool about it is the easy part, and then getting it so that everyone can consume it and actually use it for something interesting is always harder. So like build this tech, it's really cool, but it's got a million caveats as long as you have like all these other requirements and knowledge and a degree in rocket science or whatever. So that's kind of where we started, and we went to let's say like back when we started doing this, this is what the world was like at the first ClueCon, right? So like the internet, it was starting to get fast, but only at your house. Like there wasn't even like, I don't think we had like 10 megabits between us at the first ClueCon. We had to hang out. There wasn't even Wi-Fi yet. That's like, everyone was pretty bored because they had to pay attention. So nothing to hook your laptop up to. And the laptops were tiny, but we thought they were big because that was bigger than they used to be. And you can see that, James Bodie knows about that cell phone. He was peddling them back then. Like Nokia had really cool, buttons on the phone. Oh my God, I can type stuff. And yeah, and processors on computers were just hitting the 2 gigahertz barrier. So it was like, we stayed under 1 gigahertz for the longest time. I even remember reading articles about how it's impossible to reach 1 gigahertz, and then we got to 2, and then that really was a pretty big hurdle for us. So then scaling the computers were pretty hard back then too. So like everyone was pretty much similar setup, tall racks full of servers, trying to keep them from overheating. And so you had this sort of different model where you wanted to, at best, like the scaling technology would just be like, put a whole bunch of real computers in a network together and figure out a load balancer to kind of redirect transactional stuff. So it was built for the web, right? Because we started out with the web, and we used to build it that way, and then it got virtualized sometime in late 90s, early 2000s. We started to virtualize that. But there was still like this really big transition going on, and that's around the time that we were here, early 2000s, and we were working on voice over IP, and that's sort of like the landscape at the time. And when we were doing this, there was a kind of a different mentality for how we were doing things, right? So we were, thinking about the computer as the whole universe, because we wanted to make sure we didn't waste the computer because they were expensive, and we had to have the more of them we needed, the more it cost, and the more complex it is to make them work together. There wasn't really this like instant cloud kind of compute resources on demand or Lambda or any of this stuff yet. So we were like, oh, what are we going to do? We got to make this machine just do as much as it can, and that's kind of, it was a big interesting time because there was sort of only 1 or 2 cores in most computers. Like I remember the company I was at this time had one 8-core machine, and it was like insanely expensive, and we used it for a database, and that was it. Like every computer otherwise at best had 2 cores in it. When I started trying to tinker around to build FreeSwitch for the first time, it was like a single core, like half-size rack mount server, and the idea back then was, it seems like we made it to 2 gigahertz pretty easily, but it's looking pretty hard to get past that. It took us like 20 years to get to 4 and 5 gigahertz now. So really we started doing more was going full circle to the era before that and multiplying the cores on the same box. So that was like something that was changing. So when this time was come upon us, we were like, there's going to probably be a lot more cores on the server. So we have to think about that, because in this world of the whole server, not only do we want to run our software efficiently, but we have to figure out how can we actually take advantage of all these cores. Because we can, if there was one computer that had like an endless processing power, I mean, that's one thing, but when you have different threads and cores, that's like, you have to have your software doing stuff simultaneously in order to take advantage of it. A lot of software will peak out one of the processors and the other ones are idle. So that was like a big bet, because it was like, well, I think there are going to be a lot more cores coming down the line. And the other thing that we were kind of making a bet on is that cross-platform is important, because not only is it important that it can run everywhere, but FreeSwitch doesn't need, it runs on almost anything that can compile code, but that doesn't mean it's the best place to use it. But the fact that we were able to make it build everywhere, even if it wasn't a star running on Windows or Mac or other variants of Unix versus Linux or something, they all have different perspectives. Like, I think some of the best bugs we solved come from trying to compile it on Windows, even if we would never actually use it that way in real life. So a lot of people do. We're all remote people all the time, so we didn't have a lot of Windows servers. We usually use Linux, but we would compile it on Windows and there's a lot of people that wanted it to work on Windows. And just the errors and stuff that the Windows compiler would throw at us would help us. And designing it in a cross-platform way, trying to make it work in any compute environment, was kind of a goal we had, because we didn't want to be, in some kind of pigeonholed into only working in one environment, because there's different caveats and stuff. We wanted to be unique and be able to compile everywhere, and that's kind of why we did that. And there was also, virtualization was just being new. The web hosting industry had been turned into virtualization. It felt like overnight to me. It was like one day I had a web hosting company where literally they had the cases off the computers because it was so hot in the room that they were in, and just trying to throw more servers at the problem. And then suddenly there was a way to just completely just make those pure software. So that was one of the inspirations I had. Like, wow, this is a lot easier, because now I can just provision, the computer on demand, and that's what we all know what that led to, with a bunch of advents in how we do DevOps these days. But that was just new back then. And the other thing that we really cared about was modularity, because we wanted to bet on the fact that we would not know everything at the time. So we always leave a little bit of room for what are we going to do when we learn something else. So we designed it to be modular. So the work we did wasn't like only limited to the way it was at the time. So you can load, more functionality into the same paradigm. We wanted to get the hard parts right, so that we could then bring in, one day, like codecs, for instance. There's like a dozen of them. There's only like 2 codecs when we made FreeSwitch that anyone used, and but we really wanted to think forward, and that kind of helped us, because there started to be more. So things like that, extending applications and stuff like that too. But when we did this, it caused a lot of complexity. That is like the natural enemy of trying to solve every problem in the world. So we had the software that we started working on, and we had this user base was getting really big quickly, and we're thinking, we don't want anyone to miss out on something they think is a good idea. So we were like, let's just indulge every single thing anyone ever asked for. So we would get like, people would say, I wish I could do that, I wish I could do that. We started adding things. Then one day, it started to collide, like someone would ask for something, we were like, sounds like a good idea, starting tomorrow, that's true. And then like someone else would be like, but I liked it the way it was, why did you change it? So we had to start making parameters that you could, so you could have your, one side could set it one way and another guy could set it the other way, and that way you're both happy because like one man's bug is another man's feature. So, we started running into that kind of stuff, and then we have like this mess because, we're talking like multiple millions of lines of C code. Just making it compile is already a challenge. Like if you write some code and then you have to babysit it, the world around it changes. We call it bit rot, because if you don't keep up with the rest of the stuff that you might depend on to make your software, it will stop working, for sure. So it's like insane amounts of complexity that we've been working on. So really, during that time, we got to a point, where we had built FreeSwitch. People are able to use it. We have a really big community. There's a bunch of enterprise companies that are adopting it. And had to go back and reflect, like, what problem are we trying to solve? Because we knew which one we were trying to solve when we started it. There was no scalable voice over IP solution that had the kind of goals that we did. We wanted to make something that would give developers a platform to mold into something that was unique. So there's hobbyists that use FreeSwitch. There's people that use it as their own personal PBX with like 3 calls on it. Then there's like entire enterprises that build their infrastructure on top of it. And we kind of try and cater to all, right? So there's a question like, when we see what some of the things are that we're looking at today, like, are we trying to just keep the PSTN alive? Like, we made a pathway to it. We wanted the PSTN to become digitized. We were very excited about it, and not just us, but there's like a bunch of open source telecom projects in the world, including ones that already existed before we even got into it, who, the obvious thing was, let's make the PSTN keep going and we'll connect it to software. But like, there's still the problem that the whole PSTN is super arcane. And are we just perpetuating that? Or did we build software that can do all these powerful things only to purposely configure them to behave like a key system? I think it was like, that's okay to do, but like, this is a future. Like, why are we taking the internet that can have endless amount of calls and dynamically provisioned, and then we're purposely only letting you have one at a time and giving you busy lamps and a bunch of stuff like that. So like, is that the problem we're trying to solve, or is that just something you can do because we made it easier? And then, do we want the robocallers? Hell no, right? Or like, stop calling me. Like, they'll probably call me in the middle of this thing. We'll see. We don't want to do that either. We didn't make FreeSwitch in this technology so everyone could spam everybody, right? So that was not the problem we're trying to solve. What the problem we're trying to solve is, we want to usher telecom in the 21st century, right? We think about telecom all the time when we're doing this. We're not thinking of like abandoning telecom and we're just going to make some app that we want people to use or to peddle just service. We're thinking about the way telecom needs to evolve, because we have this backbone called the internet, and we're seeing this happen in other places, right? We have, I recently moved out of my house and I had DirecTV for like 12, 14 years. I had a satellite on my roof just so I could get television, right? You know, it's like, at my new house, I have Starlink. Now I get the internet through that satellite dish, and now I can encapsulate anything I want in the internet. All my phone calls, what I watch on TV, you know, so like, we don't want to make these like arcane things anymore. So that means we have to digitally transform telecom, which is a great buzzword, right? When in doubt, just say you're doing digital transformation, right? It's a cool word that means I want to do something cooler than other people do, and I want you to like me better. But at face value, it actually does mean something, because turning stuff into software is sometimes hard, and sometimes it's easy. Like, if you're just turning an app that already exists into a different version and saying you're digitally transforming it, you're not doing very much service for anyone. But like, telecom is a world full of closets with wires in it, and like, even after all these years of the stuff we're doing, there's still like these horrible solutions out there that are on-prem and physical and require you to have like this backward compatibility with this horrible stuff. Like, if it was 1970, it would be cooler, right? Because like, wow, we figured out how to like send our voice over a tiny amount of data, but now we don't want to do that anymore. There's other things that we want to do. We want to implement the telecom in software, because we don't want to have special equipment just for making phone calls anymore, right? Just like I don't want to have this special satellite just for TV when one satellite can solve all my problems. We want to do it same with telecom, because the reason we do that is that we have software-defined telecom as a goal, and that's like a world where as long as there's a computer somewhere, it can do telecom. That's what we want. We want to leverage any computer anywhere, whether it's a Raspberry Pi or some online service, you know, like an AWS instance, or our own physical hardware in a pinch, you know, like depends. Like, there's a bunch of use cases. The key is that the computers are easy to scale now, but we don't want to have to like rack up special stuff in order to just have telecom, and we want it to scale, because we're not going to make progress as society if everybody has to implement their own. Implement your own infrastructure. You know, like, that's such a burden that by the time you're done with that, like, you'd be lucky if you have any time left, and especially if you're a startup. You know, like, we're a startup at SignalWire, and we started doing this about 4 years ago. We can't afford to wait like 5-6 years for everything. You know, we decided to make that infrastructure once because we wanted to see if we could figure out how to scale that so other people can use it. So that was kind of something that we had as a goal. Again, it feels similar to when we first started FreeSwitch. We're wandering through the jungle and paving a way, and we feel like we have to do that with this new kind of era as well. Only like everything is a little easier, but there's still a lot to be uncovered. Because what we're doing this for is developers and product builders. And in order to do that, you have to really look at things differently, because developers are used to having to go hunt and find their own ingredients for things, and like, you know, you can talk and have chats about it privately, or, you know, advertise which thing you think is cooler and stuff. But like, using things in the cloud is a different era, because it's hard to think about something you develop against as a product, right? But it is. And the only way the only point of making it is so that you can empower developers. Now, we've been working on this for, I think, the time when this video came out that we have over there in the SignalWire Lounge is like talking about how 12 years have gone by, but now it's been like 5 more. This is the 18th ClueCon, you know, and it's already the, I think we're on year 4 or 5 of SignalWire, right? So we started SignalWire. I think we announced it in 2018. It was just a little baby. We didn't even do anything yet. 2019, we had raised a financing round. And then we've been hiding in a cave because of COVID for the last couple of years, but we've been, you know, we're a remote company, right? Like, we believed in this remote communication stuff to the point that we didn't have to get forced. You know, it wasn't like the pandemic said, hey, now you got to figure out how to change your entire paradigm so you can survive when you're not allowed to be in person anymore. Like, we're kind of like, our time to be in person is here at ClueCon. That's kind of one of the cool parts about it. We just come together once in a while because we would all probably die of exhaustion if we were in person because we work so much. So if we were all together, the FOMO would take over and we would just be awake forever. So we kind of resorted to, let's start a company that uses the technology we built in order to make it possible to not need to be in person all the time, but also kind of exercise some of those problems. So when we started SignalWire, it was like some of the ideas that are core to the company were already present back when we were first making FreeSwitch, because it was so early, it was hard to do. You know, like we couldn't do everything we wanted to do at SignalWire when we started FreeSwitch because it was kind of the Stone Ages in comparison. You know, there was a lot of things like not everyone was ready for the cloud, another buzzword, right? We all know that's the internet. You know, but it's a cooler word than the internet. So we'll keep saying it. Just replace it. If I say cloud, I mean internet. You know, we have these people that have been like killing themselves trying to figure out how to take the same computer and make it do cooler and faster and easier things. And we wanted to trap that complexity that why make all the same crap over and over and over again just the pedestal to put your app on. We wanted to find a way that we could, you know, build something that can do some of that for you, but still give you all the cool stuff, because you're still going to have to change things. So you're going to have to develop, you know, like there's no out-of-the-box developer product. Like the whole point is that you guys are the ones that have to make it something cool. You know, it's just like if there was art project, we wouldn't make you weave your own canvas first. You just want to paint the picture, right? You're going to invent your own paint and like cooking on the stove and stuff. So you waste so much time, you know. So we have this global community, and the needs of what the community wants to do are going up, because adapting to that whole the new world where we have like this unlimited bandwidth everywhere and unlimited internet is starting to make sense, right? Like what could we do that we build on it? So then we want to know, like, where are we trying to go with this? You know, here when we started SignalWire, we're wondering, you know, let's continue some of the things we did at FreeSwitch. We want to reduce the friction, and we want to automate the scalability, because now we're not just trying to make the best out of one computer, we're trying to make the best out of like a cluster of them, and sometimes they're not even real computers anymore. They're imaginary computers that kind of all work together. You know, they behave like computers, but you can't even count on the behaviors because they, you know, you're sharing it with people. You have to, and making a real-time application scale is even harder in this environment. And we want to eliminate some of that complexity, because there's a lot of those parameters and stuff that made FreeSwitch so hard that we want to also pass on the part that makes sense and not necessarily only, you know, continue to tie everything in knots. Now, this is something that I started thinking about in 2008. It was, you know, that's probably 2 years into the entire FreeSwitch project. So like, FreeSwitch has been around since 2005, but as early as 2008, I started thinking about like how can we make this thing work in kind of a way that removes the boring part, so it kind of leaves you with something to do that's unique to what you're trying to build. And eventually came up with the name for this, and I'm going to start talking about it now. So I don't want to be boring here, but I have ClueCon as my sounding board, and that's what I did when I made FreeSwitch. So I'm going to talk about what the next vision is right now, and it's called Call Fabric. So our company has been hearing this term a lot lately, but the public, I don't think I've really mentioned it a lot. So I'm going to start doing that now, because it's just the way that my brain works and how I like to gather feedback. So I'm going to tell you about Call Fabric here at this keynote, and then you're going to talk to me in the halls and at the party and stuff and tell me anything you think about it. So I'm going to explain it. What is it? Well, as far as SignalWire is concerned, it's the next iteration of our platform. We sort of had a initial goal of building the core infrastructure for our network. And then step 2 was to figure out how that we could scale and automate and make things easier, but still continue to have it be an environment that you can develop against. And to me, it's like, to actually have software-defined telecom scale and not just be another buzzword, we need to be able to deploy it and have it work and be able to allow you to build stuff. And really, like, another way to look at it is, the unification of RTC and CPaaS and UCaaS and all the asses. You know, like there's so many of them. You know, which one are we talking about today? Between us, like UCaaS isn't actually a service. It's just a cool name for an app. I jokingly also call this project UCaaS ass because it's like allowing you to distribute UCaaS instantly, because UCaaS itself is just an application, and it's not really like something you can consume without adding a double ass on there. So that's what we do as a joke. You know, and so I'm going to talk about what we have as an idea for how we're going to break things down. And we wanted to think about, you know, we've lived through, the team here goes back to Asterisk days. So SignalWire employees have worked on Asterisk. We helped make Asterisk, you know, and we know the best parts of it. We made FreeSwitch also. We were inspired. We had different ideas, but some of the things made sense that were already there. So there's a little familiarity that kind of lingered on, like homage to that era. And then all these years of making FreeSwitch too, and we made a lot of complex things, you know, over the years. And we wanted to figure out, like, how could we just make it a little simpler but still powerful? So we started with something called resources, right? And a resource is essentially anything that can be communicated with, any software entity that lives in the internet that you can call, right? Like I can call it on a phone call, I can call it on a video call, I can even like set up a chat conversation with this thing. So a resource is something that is designed to receive and communicate over telecom network. So the idea is that some of you might be into object programming. If you want to think about it that way, the resource is sort of the base class of what we're building in Call Fabric, right? So a resource is a high-level object that there's variants of them, but they all have some things in common. So they'll be accessible over every possible communication path that exists. So they'll be accessible if you want to give them a phone number and call them with grandma's landline, you will be able to. If you want to give them SIP addresses over the internet, specific ones, you can do that. If you want to just have a literal HTTP URL and you go to that in your browser, you'll be starting a call with it, regardless of what type it is, right? And if you want, you can also make your own purposeful client that might have a little bit different take on how it communicates, but underlying SDK doesn't have to change. And so all those things can be talked to over any of the mediums we come up with. And we're actually not sure, there won't be more, but for now, we're focused on video, audio, and messaging, because those are the ones that we all know the most. So we're, you know, I want to be able to communicate visually with it through video. I want to be able to talk or send sound back and forth, and I might want to send messaging. And it might be like emojis and thumbs up icons and stuff, or it might be data control structures that you might want to tell your application some interesting private stuff, you know. And we want to make it so you can provision them over, you can go on a UI that will have a convenient UI that will allow you to kind of set everything up, but you can also provision automatically with REST. So the idea behind this is like a lot of things that we've like suffered through, we think are easy, and other people kind of look cross-eyed at us and are like, oh, it's easy. You just got to define a dial plan and put blah, 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 and set up all your variables. And like, we wanted to just make something like, what does that all have in common? So that's when we came up with the resources, and that's what we're calling it. And then the types of resources, we wanted to start with a small number so that we don't go insane, because we want to avoid the complexity problem. We want to actually simplify things. So these are the core resources we have right now. So we have subscribers, rooms, call routers, and scripts. And we're going to see if we might need another one, but for now, that's the ones that we're focused on. And subscribers are the first one, and that's essentially a user account. Think of it that way. That's like a simple, like the way a subscriber would be thought of in like a mobile network or something. A subscriber is someone who, a device or a person that has a unique identifier, you know, that's phone number 7 or that's Fred, you know, but either way, you can like make and provision an account that represents that person and all of their preferences, or that device if it's a physical world, you know, or it's a robot, doesn't matter. But that identity is managed, and you can route calls to it or have it make calls to other things. And same way, we want to make it so you can just provision them automatically. So you say you're building a company, you want to manage your resources on the global network. In hyperscale it instantly, you just make a sign-up page, collect the data, send to REST control, you can create the user. Now the next key ingredient is rooms, right? So rooms are another, conferences is another way to put it. It's a group, it's an object that multiple users can connect to and get the media flow. So whether that's, again, audio, video, or messaging. We've all got those in the world. I'm sure everyone goes in like Slack or whatever. You can think of it that way. Think of it like any video conference and like the way Zoom works or any of that kind of stuff. But instead of thinking about it as an app, think about it as an object in your program. Like, I just want to wish there was a room and then it exists. So now I can talk to it and I can control it and I can do everything I want to be able to interact with it, get events about it, and make some kind of integration with some other cool software. And we want to expose every possible thing you can think of, so making the room is the easy part, and then why you're going to make it cool is the part you get to worry about. Next one is a call router. So a call router is kind of the evolution of, we've gone through multiple iterations of like, how do you decide what to do? You know, Cisco had dial plans. We called them dial plans. The Asterisk had dial plans. In the free switch, dial plan was a type of module. You know, we thought, you know, people are going to figure out how to do call routing and like at low level tie it into their infrastructure. In this version of it, we're thinking, how can we collect the most obvious things that you want to do and turn them into just a to-do list of parameters that you can instantly provision. So say you want to do like set up a call flow. You want to have like someone tries to call a SIP address or a number or something, you want it to do like an intro video first and then transfer you into a room, or you want to have it like check what time it is and like send it to an overnight call center when there's no one at the office, or you know, make a call center API of some sort where you want to be able to flip the switch around and just kind of manipulate the entire call routing logic from the convenience of REST or UI. So you're playing around, you can do it on UI, you make something serious, you use controls, and you talk to us with the API key, and you can like move things around instantly. Let's say you do a lot of traffic and you want to record calls, so you can route the call into this and get a recording and have a post back to you or whatever, but then go back to your regular business when you don't need to do that. A lot of different things. You want to take all the other resources in your collection, but you want to have some more specific logic to it, then you use a call router. So then scripts are one step up from call routers, and scripts are something that was one of the first things that we did when we built SignalWire, was make a way to use scripts. So this has been something I've been working on since day one. I tried Asterisk as a newbie way back, and they had like this manager protocol or something, and I wanted to be able to do cooler stuff with that, and they had AGI, and I'm like, I think it's sort of cool, but it needs some more work. So like, then we made FreeSwitch, and then we made something called Event Socket. It's like, this is a lot more powerful than what we could do before, but it's still not super secure, and it's like doesn't scale very well. So like, what can we do further? So then meanwhile, while we were in a kind of an academic cycle trying to build this technology, there's been other companies that have kind of made what we would call like the Gen 1 of CPaaS or whatever. So we've got some variations of XML protocols and whatnot where you can sort of use webhooks to control calls and that kind of things. You know, so like in this paradigm, if you want to do something harder than what the call router can do, you can route it to a script, which is something that you can control, you know, either from a remote webhook. We're working on a serverless thing so that you can kind of just deploy it to us and let us do everything, including a static document-based, like a next generation way to express like an entire phone call's behaviors in a single data structure, so that you can just deploy that instantly. And that's going to be like a cool way to do that. And one of the ways, like, we have two kind of ideas on that, and we want to focus on the static world because we want things to scale. So we make them static. It's easier to do multiple times, you know, thousands at a time per customer in the whole universe, right? So we're thinking big like that. So we invented this thing called Relay. In fact, I think we were literally, like, you know, our hackathon challenge at SignalWire for 2019 was literally to make SignalWire in front of everybody at ClueCon. So like we were only like a couple months old at the time, and in the middle of ClueCon, our engineers were building the stuff, and people were trying to make stuff out of it in real time, like right on the day we released it. So one of the things that came out of that was Relay, which is sort of a next evolution of some of these real-time call control stuff. So what we wanted to do is like still have, you know, open source SDKs and code and things that you could change and add to, but be able to control at volume with hyperscale the calls on the other side. So the idea behind this is that it's container friendly, you know, because it's designed so you can deploy, like you could have a whole 100 Docker images of Relay, and like all your calls will be distributed equally to them. And what it basically does is gives you like a super lightweight, instantaneous kind of WebSocket thing that will wake up. You can write it in whatever language you want, but you know, Node is one of the better ones for asynchronous stuff. You suddenly, you know, you're already starting at square one with like an application that will scale, that gives you your own function callback as soon as the call happens, and you can do all these cool things in a more safe and secure way. And, you know, like creating IVR menus or playing back stuff, or taking the audio stream and piping it to a different application, or doing analysis on it, and any of that kind of cool stuff instead of the boring part about getting the calls to work in the first place. And it's really like designed around asynchronicity, which is why I said Node is one of the better ones. Probably next in line is Python. You know, but like anything that can communicate over a WebSocket can be turned into a client. It's a very basic protocol. If we had a challenge in this room to write a JSON protocol that would allow you to control calls, you'd probably all come up with something similar. So we tried to make it super easy. The important part was like being able to do the thing at scale. So the way this all ties together is there are things that we call contexts. Now, context is a familiar term in a lot of the software projects out there. Asterisk had them, and FreeSwitch has them also. And it's really like realm could be another word. Like we always do this when we make software, when we figure out how to containerize our different things so that we can give them permission models and stuff. So contexts are kind of the glue that will allow you to take the resources and make them available. So if you take, say, like an example from FreeSwitch, we have it comes out of the box with like a public and a private SIP profile that goes to a public and private dial plan. There's a lot of people who download it and run it like that forever and don't even, they just kind of edit it a little bit. But for the idea behind that was supposed to be to separate out your stuff, right? And if you get more involved in it, you might learn like, oh, I can make like dynamic contexts and I can use it to auto route things and that kind of stuff. So we wanted to be able to do that. We wanted to make a way to do that also without, say, like, having such a huge learning curve on it, but also like harness that power, because we want to use FreeSwitch too, right? Like, you know, we made FreeSwitch and it took like 12 years to try and actually make anything out of it ourselves because we're so busy making it, you know, more and more complex. And like, how can we actually, like, let's work on making it easier for once instead of complex. So, you know, we bring it together, and the kind of the use cases that we're focused on right now is like, we want to make a way to host the products in a way that you already have to use a computer somewhere on the internet, and you already have to do a bunch of DevOps. It's like, can we simplify that in a way that kind of breaks even with you, as far as you can trade, say, like your expertise over to a different part of your company, or if you're like amazing at it, we want to give you such low-level interfaces that you could weave together your application logic and build stuff so that you don't have to create this kind of like like a lot of people used to make their own email server. I used to be up all night because the spammer would dictionary attack it, and like I used to have to write a payment gateway from scratch. You know, so some of those things that I'm happy about now, that I just use a remote API over to Stripe when I want to take a credit card, or if I want to, you know, our company just provisions an email account over at Google or something instead. So we wanted to kind of follow in that idea, like, let's not like take over the entire thing, but let's make a way so it's easier for everybody to build stuff. So that's the end of my explanation of that. I hope that it makes sense, and then if you guys have any questions about it, it'll be great. And I have a little extra time, so what I wanted to do was talk a little bit about our community, right? So we started a community with like an IRC channel one day. Like we just created an IRC channel. There's like 3 people in it. We kept trying to invite people. It grew, got a couple hundred one day. Next thing you know, like we're releasing software and there's a lot of people using it. There's enterprises using it. And all along this community has been growing. And the world has kind of evolved around us there too, because one day we're sitting there and how are we going to have a community? Let's just like go on IRC and tell people to call. We used our own servers to make like a room that we could meet in. And we had a mailing list, like super old school mailing list. And it started to get old also. You know, one day we realized it was like that software wasn't getting updated very often, and the whole world has switched to all these dynamic applications and stuff. We're like, well, we have to do that too, because we want to engage the community still, and we found that we were sort of falling behind on that. So we went through a couple different things. Like we had HipChat for a while. I don't know if you guys even remember that thing. It was like, it was better in IRC, but it didn't, not much, right? So then that kind of evolved into Slack, which most people use, or Discord, or one of those kind of things. So we're thinking about like, how can we get back to having a little bit of bringing the community voice to the top of the conversation and have advocates for the developers and for the community members. So one of the things that we did was to make purposeful roles in our company SignalWire so that we could attend to that. So one of the people that are new to the company who is focused on that exclusively, and someone you should get to know really well, is Alex, who's coming up here just to say hi. Like, she has a talk later, so you should make sure you come to it because you'll learn even more about it. But you know, we're going to do a lot of really cool sort of community-based things so that we can usher our community into the next generation too, and like move on from just email lists and status quo. So say hi to Alex, everybody.
Hey, everyone. Can you hear me? Do it sound okay? Sweet. Hey, everyone. I see a lot of faces out there that I haven't met yet, but this is the opportunity for it. So I will be around all week. Please come talk to me. Tell me what you like about the community. Tell me what you're looking for. Talk to me about Discourse, Slack, whatever you got. And also, I want to invite you guys to join the Discourse. The front page of your ClueCon booklet has the link, and that's where we're going to be posting a lot of cool ClueCon updates. The big benefit is that you can actually reference it more than 3 months out, unlike Slack. So you can check the stuff out and actually see next year people can see what we did this year, and it's actually a persistent, like, searchable history. So come check it out and come talk to me if you get the chance. Thanks, everyone.